This is a recording of the Chapter 5 practice test for sections 5.4 to 5.6. And this is actually the second version of the practice test that we are looking at. This is version B. We did version A in class yesterday. So what I want you to try to do with this practice test is go ahead and do the problems. If you have to pause the video and do the problem yourself, and then run through it with the video running and see if you had the right answer. So for number 1, go ahead and use the synthetic process to find p of -2 if p of x equals -x to the third plus 4x squared plus 6x minus 2. Again, go ahead and pause the video and give that one a try. Now I'll go ahead and talk you through the answer. So this one says find p of -2, and that means we are supposed to put -2 into this function, but we're supposed to do that synthetically. So that means we're going to use a -2. We're going to check to make sure this polynomial is in standard form, and I see an x to the third, an x squared, an x to the first, and a -2, and just use the coefficients. So a -1 x cubed, 4x squared, 6x, and a -2. And remember, if anything is missing in there, you have to use a 0 as a placeholder. And then for synthetic division or synthetic substitution, as this is known when we do polynomial evaluation, we bring down the leading coefficient, and that's where we start. When we're outside the box, we multiply by the a value in x minus a, which in this case is just -2. And -1 times -2 is 2, and then we go inside the box. Inside the box you add, so 4 plus 2 is 6. Outside the box you multiply by that a value, so 6 times -2 is -12. Inside the box you add, 6 plus -2 is -6. And then we have -6 times a again, back out in front by -2, that will be 12. And -2 plus 12 inside the box is going to be 10. And that last number is what we'll get. And a good way to double check this is just go ahead and put -2 in parentheses in for each of these positions in the polynomial where there's an x, and actually do the math on your graphing calculator and make sure that you get 10. But again, that's just to check, because this said use the synthetic process, and that process is complete. Number 2 says divide synthetically. So go ahead and pause the video. Give this one a try. The solution to this one comes from the fact that we know that we're using x minus a in those factors. So instead of using a -3, we should be using a +3 to divide this by. And that all comes from, again, the fact that our factors all looked like this, the x minus a piece. Now, as we go to do this problem, the key again is to make sure that it's in standard form and that everything is accounted for, including the constant, the number in the back. So 3, 2, 1, 0, they're all there, and that's just checking that we have it in standard form, highest power down to lowest power. And we have 1x to the third, 4x squared, -26x, and 18. And then we do the synthetic process just like we did in number 1, so I'll go a little faster this time. Bring down that 1, multiply, then add, multiply, and then add, multiply, and then add. But this isn't like the problem that we did in number 1. We're not just interested in that last number here. This last number is our remainder, this is our constant, this is our x, and this is our x squared. So that means we have x squared, and that's 1x squared because of the coefficient right here of 1. And then we have 7x, again, there's our coefficient for that one, minus 5 is our constant. And then we have to write our remainder properly, and that means we're going to write plus 3 over what the divisor was. And the divisor was x minus 3. So in this little bitty blank here, we would write x squared plus 7x minus 5 plus 3 over x minus 3. And that would be the correct answer for dividing that synthetically. I will clear this off while you go ahead and pause the video and start working on number 3. Number 3 again, we notice our x minus a format, and that means we're just going to put a 1 out in front. Negative 2x to the 4th minus 5x plus 7, we are missing some things. So we have a negative 2x to the 4th, but we don't have an x to the 3rd, so we need a 0. We don't have an x squared, we need another 0. Negative 5x and 7, all the way down to the constant. Bring down your leading coefficient and go ahead and do your synthetic division. Negative 2 times 1 is negative 2, 0 plus a negative 2 is negative 2, times 1 is negative 2, add the 0, you get negative 2. Negative 2 times 1 is negative 2. Negative 5 plus negative 2 is negative 7. 1 times negative 7 is negative 7, which gives us a remainder of 0. But we have a lot of answer left here. And again, this is division, so we have to write the polynomial answer. Remainder constant x, x squared, x to the 3rd. So we would have negative 2x to the 3rd minus 2x squared minus 2x minus 7. That would be the polynomial that is our answer because we do not have a remainder on number 3. Now for number 4, which is long division, again, pause the video, give this one a try. Solution, first of all, we should realize that there is no way to divide this one synthetically, and that's because this factor is not in that x minus a format. So we will have to use long division here. And we have 6x cubed plus 19x squared minus 34x plus 9. So it's there and it's in standard form. Nothing is missing. Again, if anything is missing, we'd have to make it a 0 as its coefficient. So we start with our 3x minus 1. And we realize that what we really have to do is get rid of 6x cubed. That means we have to multiply 3x by something so that it will become 6x cubed. And that would be 2x squared. So you multiply everything in the parentheses by 2x squared, and you get 6x cubed minus 2x squared. And now what we have to do is change the signs and add. Because 6x cubed minus 6x cubed is 0, which is what we wanted, we know that our 2x squared has worked, and we'll put it up at the top. And then we're not done yet because we still have 19x squared plus 2x squared, which is 21x squared. And then you bring down the next term. And we start over again with our 3x minus 1. And again, we only focus on the first term. We need a 21x squared. 3x times 7x will get us that. And again, the focus is just on the first term. That would give us 21x squared minus 7x. Change the signs and add. So our 7x is definitely working. We're going to put that right up on top. And 21x squared minus 21x squared is gone. Then we have negative 34x plus 7x, and that is negative 27x. And you bring down the last term. Start back over with 3x minus 1 and think, how do I get 3x to be negative 27x? I would have to multiply by a negative 9. That will give me negative 27x plus 9. Now, it's definitely going to work because if we change the signs and add these, negative 27x plus 27x is 0, and 9 plus negative 9, or 9 minus 9, is 0. So there's our remainder of 0. And that means our answer, our quotient, is right up here because it worked perfectly. 2x squared plus 7x minus 9. Again, remember, if there is a remainder, after you write all of that, you write plus whatever the remainder is over 3x minus 1. But in this case, we did not have a remainder, so we didn't need to do that. Go ahead and read number 5 and stop, pause the video, and then you can look at the answer after you're done. For number 5, this is just a list of the possibles. And the list of the possibles come from checking to make sure that the x's are in descending order, that it's in standard form. And we have an x to the third, x squared, x to the first, and a constant. And now what we have to do is put all the factors of the constant on the top of a fraction. The numbers that divide nicely, integers that divide nicely into 7 would be 1 and 7. And then the bottom of our fraction comes from factors of the leading coefficient, which in this case is 10. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. And then we actually write out the fractions that exist for this problem. So we take this 1 on top and put it over the top of everything that we see in our denominator there. So plus or minus 1 over 1 is 1. Plus or minus 1 over 2 is 1/2. Plus or minus 1 over 5 is 1/5. Plus or minus 1 over 10 is 1/10. And now our hope is when we go back over the top, because we're done with the 1, when we go back to the 7, that maybe we'll get some repeaters that we don't have to write down. Unfortunately for this one, all of these are brand new. So 7 divided by 1 is 7. 7 divided by 2 is 7/2. 7 divided by 5 is 7/5. And 7 divided by 10 is 7/10. So we need all of those plus and minuses in there because factors can be positive or negative. And then we need to make sure that we are writing these out as fractions. And that's all we had to do for this one. This one is just list all the possibles. Go ahead and take a look at number 6. Pause the video and try to do number 6 on your own. It says we are responsible for finding all the zeros of the following function. And like it says, we have to show work for credit here. So the first thing we would do is list those possibles, just like we did in the last one. And think, well, with a 6 in the back, I'd have a plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 for my numerator. And then my denominator with a 2 in the front would be plus or minus 1, plus or minus 2. So if I wanted to write all of these possibles out, I'd have 1 over 1, which is 1, 1 over 2, which is 1/2, 2 over 1, which is 2, 2 over 2, which is 1, and that's already up there, 3 over 1, which is 3, 3 over 2, which is 3/2, 6 over 1, which is 6, and then 6 over 2 is 3, which is already in my list. Now, because this one didn't ask us to actually list the possibles, you could skip that step. But that gives you a good idea of what you're looking for when you graph it, because the next step would be, how can we solve this? And you might want to go ahead and try factoring by grouping, but you're going to notice it doesn't work in this one. If we take an x squared out of the first two terms, we get 2x plus 1. And all we can take out of the back terms is a -1. And obviously our parentheses don't match. So this one cannot be factored by grouping. The next thing we would do is grab our calculator and punch it in. And we would try to find zeros either from our table or from using Blinky. So zoom 6. Hopeful that we'll see some nice zeros here. And we go into our table because it does look like 2 is pretty good and -1 might also be good. So let's check those out. So -1 is working. We see a 0. And it won't stop going now, so I'll give it a second to come back up there. There we go. -1 is a 0 and so is 2. So that's a really good place to start with those two nice numbers there. And when I say start, I mean, hey, we need to do synthetic with these and see what happens. So -1 and 2 look good. I'm going to start with -1, making sure everything is in standard form and that nothing is missing. 3, 2, 1, 0, all the powers are there. So we take those leading coefficients and we do our synthetic. Bring down the 2, multiply, add, multiply, add, multiply, and add. So this is good news. That means our -1 is working. Then we try, because this has already been worked down, we try the next one that it looked like was going to be good, which was the 2. So bring down that leading coefficient, multiply, add, multiply, and add. And And that's excellent news. That means our -1 and our 2 work. Now, the last one we will get from reading off what we have for remainder, constant, and x. We have 2x plus 3, and we need to find that remaining 0. So we would subtract 3 from both sides. 2x will equal -3. Divide both sides by 2, and x will equal -3/2. Now, you could have done synthetic with that -3/2 if you used Blinky, second trace, to figure out where that last 0 is. So right now, Blinky's kind of lost in here, and I need Blinky to tell me this 0. So I go to the left of it, and then I go to the right of it until it's above the x-axis, press enter, and enter through guess. -1.5 is -3/2. So if you used Blinky and found that, you could just do synthetic on this last piece with -3/2 as your fraction. So you bring the 2 down, and -3/2 times 2, the 2's would cancel out, and you would get -3, 0. Either way, whether or not you use an algebraic method or you use synthetic, you did verify those zeros. So -1, 0, 2, 0, and -3/2, 0 are your 3 zeros for that function. So that's a good one. That has a lot of pieces, a lot of math that we have to look at. So now go ahead and pause the video and give number 7 a try. Word problem. The product of 3 consecutive integers is 12,144. Write the polynomial equation in factored form and solve to find the numbers. Verify your answers synthetically. So there's quite a bit going on here. We have to remember that consecutive integers are numbers like 1, 2, and 3. Numbers that are right after one another. So if I make the smallest number equal to x, that means the next one is going to be x plus 1. And the one after that will be x plus 2. So my polynomial is going to have x times x plus 1, because this said product, times x plus 2 equals 12,144. Now that's the first part of it. It said write the polynomial equation in factored form. Done. Solve to find the numbers. We want a polynomial. So what we'll do is we'll do FOIL on these two and then distribute our x. So let the x hang out for just a second while you do FOIL on x plus 1 and x plus 2. X times x is x squared. Outside times outside is 2x. Inside times inside is 1x for a grand total of 3x. Last times last is 2. And then distribute your x through the parentheses. So x to the third plus 3x squared plus 2x equals 12,144. And then we need to subtract 1,244 from both 12,144 from both sides to get our fabulous looking polynomial x cubed plus 3x squared plus 2x minus 12,144 equals 0. And now what we will do is we'll use the graphing calculator to find that 0, knowing that this has to multiply to 12,144. So we put this in our calculator, and I start thinking, well, if it has to multiply to 12,144, I'm probably not going to get away with my 0 to 10 window. So for my window, I'm going to try 0 to 30 for my x's. And it's not taking a 0. There we go. And I know my y has to get to 12,000, but I don't even necessarily have to mess with that, because what I need to know is where it crosses the x-axis. But just to make this a little bit better for everybody, I'm going to go ahead and go to 13,000, because that obviously is higher than 12,144. And hit graph. So right here, where it crosses the x-axis, that's where our answer is. And I remember that this was 0 to 30. That's what I put into the calculator. So 29, 28, 27, 26, 25, 24, 23, 22. Let's go to the table and make sure that 22 gives us a 0. And again, this is going to take a while with this one. Because I need to get to 22, and it doesn't necessarily work when I hold down the button. There, it's going a little better. There we are. So, at 22, we do see our 0. Now, we're only human. We may have punched something in wrong. So, go over here, and we write down that we're pretty sure it's 22. But that's why this says verify your answer synthetically. We have to make sure that 22 is going to work in our polynomial. And this is in standard form. We've got a 1, a 3, a 2, and then an enormous negative 12,144. And we have to make sure we get a remainder of 0. So you bring down the 1. 1 times 22 is 22. And then 3 plus 22 is 25. And then you have to take 25 times 22, and that's 550. And you add the 2, and you get 552. You take 552 times 22, and you should not be shocked that it's 12,144. And it does give you a remainder of 0. So, write the polynomial equation in factored form. Did that. Solved to find the numbers. We've only found 1. We found 22. But we know these are consecutive integers. So that means they have to be one right after another. So it has to be 22, 23, and 24. And to check this, you could punch into your calculator 22 times 23 times 24. And make sure that it comes out to 12,144. That is the second practice test version B, for the 5-4 to 5-6 test.